Today I want to talk about object-oriented programming in JavaScript. In my experience, many programmers coming from Java and other class-based OO languages are confused by JavaScript's prototypical nature. We will cover this new prototype constructor and a much simpler approach to which provides true encapsulation. Okay, so our goal is to implement this make account function, which should make an account, and what should we be able to do with these accounts. So we should be able to make more than one of those, in this case two. We are very interested what happens when we log them to the terminal. We want to deposit an amount of money to those accounts. We want to see how much money is currently stored in these accounts. And this is a technical curiosity. Do multiple accounts share the same methods, or does every account has its own method? Okay, right, so what's the first approach that comes to mind? So this function should make an account, so let's simply return some object, right? So inside these curly braces we can write all the properties that this account should have. So for example, it should have a balance, which should be based on the initialized by the initial balance. That's why initial balance is a good name. It should have a deposit function that takes an amount of money and simply adds it to the to the balance, like this. And we also need the get balance function, which simply returns the balance, like this. Okay, let's see if this already works. So let's start Node with our example program and let's see what happens. So we made these accounts. That doesn't produce any output on the terminal. Here's our first console log that gave us this output right here. So we can see before we do anything, the balance is indeed the balance that we chose for the initial balance, and the same over here for B. Okay, and we can also see that there are deposit and get balance properties, which were initialized here, which are functions, right? So you can see those are functions and those are the names of the functions. Okay, then we deposit some amount, and the get balance function shows us that the deposit function indeed worked, right? So here we get 23 more, and here we get 234 more. And we can see that the comparison between the methods shows us that each account has its own methods, even though that's not really necessary, right? Because it's the exact same code. So JavaScript was invented in the 1990s, where memory was measured in megabytes. So when you could save a few kilobytes or tens of kilobytes, if you had, I don't know, thousands of objects in your JavaScript program, then that was deemed important. Okay, so the next step is to get this Boolean to turn to true. We want to share those methods between accounts. How would we do that? Let's do a manual approach first, so we can concentrate on this proto, and we'll get to the other stuff later. So I want to make an object for the account methods. Let's maybe call it like this. Let's call it like this for a good reason, where we simply move the methods into. That would be those guys. Okay, can get rid of those. And now our program won't work anymore because there's no connection between the accounts that this function creates and this object with the methods, right? We haven't connected those yet, so this should give us an error. Yeah, deposit is not a function. So a deposit, don't know what it is. It's not mentioned here in this list of properties. Okay, so every time JavaScript looks for a property on an object, it doesn't simply look just inside this object. It also looks in a linked proto object. And I can say, hey, if you don't find deposit or get balance, you can simply look in the account methods object and see if you have luck over there. Let's do it like this. Okay, so now we should get a better result. Now you can see the accounts only have the balance left. The methods are no longer stored inside the accounts themselves, but the rest worked successfully because the deposit function was found indirectly through this proto object. Okay, and you can see that the accounts share the same methods now. They are only created once because this code only runs once, right? Okay. Right, so that should hopefully clear this up. So what happens under the hood, if you will, is that JavaScript inserts this proto over here because deposit is not part of A itself. So this should work as well. Yeah, but you don't have to write this yourself. JavaScript does it automatically until it finds the deposit property. Okay, so that would be that. Now let's get to the next point. Right, so here we created the object with the methods ourselves, and there's a way to have this handed to us by JavaScript. So the first thing that we do is replace this make account function or replace the name. Let's just call it account with a capital A. This is a convention that says, hey, functions with a capital A should be called with a new keyword. This is just a convention, but you should really follow this convention. And what happens then is the object that we want to return from the account function is already created before the account function is entered. So we don't have to create it ourselves. It's already there. Okay, so we can simply say now this, which is the new object that was created for us, and then dot balance equals initial balance, and we don't have to write the rest. Okay, so now we should get a crash again because these methods won't be found. Let's see. Yeah, there's our next crash. Deposit wasn't found. Okay, so what we could do is say, well, the proto should be account methods again. Let's see if that works. Now it works again. But we don't have to do this ourselves. So what JavaScript does under the hood, it says the proto of a new account should be the same as account.prototype. So this account.prototype was created by JavaScript in the background, and it was created basically on line 15. So every time the JavaScript engine sees that you're defining a function called f, then an object called f.prototype is automatically created for you. Okay, so we don't have to write this yourself. And now we can simply add those methods to the prototype. So let's do that. So account.prototype would be a function. Now we can cut and paste from here again. There we go. Okay. And oh, I'm sorry, I forgot the deposit, and the get balance would be this function. There we go. Okay, and then we don't need this guy anymore. Yeah, let's see if that still works. Yeah, that still works. And what you see, not only is this line created for us, there's another line created for us, which is account.prototype.constructor equals account. So that's why the account object knows that it was created by the account function, right? So if you have a any function, but you should only use the prototype for constructor function. So if you have a constructor function and go to the prototype, then via the constructor property you can get back at the constructor function. So this is a cyclic dependency, if you will. Okay, and that's why every account can remember how it was created, or every object can remember how it was created. In this case, it was created by the account function. Okay, so that's handled automatically for us. Okay, now some people don't like this piecewise assignment of one function after the other to the prototypes, some prototype properties. You can do it in one big swoosh if you want. So we can simply override the prototype property and say this should be a function. Now I have to copy paste again, where the deposit, I'm sorry, it should be an object with a deposit property and a get balance property, and both of those are functions like this. Okay, and now we won't need those anymore. Let's get rid of them. And now you will see a subtle difference. Now the information which constructor function created the account is gone, because this line is basically missing here, right? If we want to manage our own prototype object, then we have to fill the constructor property ourselves. So constructor should be the account function, and then it should work again. Yeah, there you can see. And it's not only for nice terminal output, it's also so that some other inheritance stuff works better in JavaScript, like the instance of operator. Okay, and I forgot a semicolon, that's bad style. Right, that's that. So that's the classical prototype approach to JavaScript, which was used for quite some time. Okay, then a couple of years ago in ECMAScript 6 standard, enough Java programmers had complained about this weird syntax. They wanted something more familiar in JavaScript, and now you can simply write class account, then you can put the constructor function inside and call it constructor like this, and then you can simply write deposit amount with the same body as before like this, and you can say get balance with the same body as before like this. Oops, not without the function. Okay, then we don't need this anymore. Okay, and that should give us the same result, yeah, and the output is exactly the same. So this is a rather controversial feature, because at runtime there's no such thing as a class in JavaScript. So this familiar looking syntax to Java programmers generates the exact same object structure at runtime. Okay, so JavaScript programmers don't really like this because it gives a syntactic illusion of having classes, and Java programmers love it for the exact same reason, right? They don't want to have to think about all these prototypes, even though that's what really is happening at runtime. Okay, that's that. Now, the last point, how should I motivate this? So this balance property, as you can see, is visible from the outside, right? I could manipulate it to my liking. I could simply say, hey, the balance should now be 1,000,000 from anywhere in my code. And of course, object-oriented programming, one of the cornerstones of it is encapsulation, right? Only the methods should be able to access the balance, not some arbitrary other code. So if something goes wrong with the balance, I know where to look for the bug, hopefully. Okay, so maybe let's go back to our very first approach. Okay, let's see what we did at the very beginning. It looked like this, and we didn't use new. We did it like this. Does this still work, or did I forget anything else? Yeah, it still works. Okay, now we are back at the objects which have both the fields and the methods, if you will, like if you look at it from a Java perspective. And we would like to get rid of this. in the outside view. Okay, so how would we do that? Let's see. So the problem is if the methods access this object, then there's no way to hide those properties, because you're just accessing some objects, some properties of an object, and you can't really make them private. That's not possible in JavaScript. So what they should do instead is they should act on variables that are scoped to this function so that nobody else can see them but code that I just highlighted. Okay, so I could, for example, say, well, balance can be a local variable like this, and then I remove it from the object like this, and then I remove those disqualifiers, and now we should get an interesting result. Let's see. There we go. Now I can see, if you compare the outputs, that the balance has disappeared. So if you now tried to access a.balance, you would get an error, right? We can let's see if we can do it. For example, here, let's try to access the balance directly. There we go. Undefined, right? So an account does not have a balance, which seems very counterintuitive to Java programmers. So what happened over here? So those methods, whenever they called, they act on a variable that is scoped to the function makeAccount, which has long returned, right? As soon as we assign this account to A and this account to B, the balance is no longer in scope, but it's still in scope inside those methods, because JavaScript has lexical scoping. Right? Okay, so only these two methods can access balance. Nobody else can access it. So that's very cool. And what's also very cool is you don't have to explain this. You don't have to explain proto. You don't have to explain new. You don't have to explain prototype. And you don't have to explain constructor. Right? You just make an object that accesses some local state that is somehow preserved via the magic of closures. Okay, and we could even get rid of the balance variable if we simply renamed the parameter to balance, right? This should work as well. Yeah, gives us the exact same result. So that's what modern idiomatic JavaScript looks like if you care about encapsulation. Okay, I hope this cleared some things up, and I'll see you next time.